My topic is all about theorems on roots of equations, such as quadratic equation, polynomial, and remainder theorem. Let us define first what is a quadratic equation. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in standard form ax squared plus bx minus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Example of quadratic equation: x squared plus x minus 2 equals 0. 2x squared plus 3x plus 1 equals 0. Solutions or roots of quadratic equations are the values of the variable or variables that makes the quadratic equations true. Quadratic equations that can be written in the form x squared equals k can be solved by applying the following properties. First, if k is greater than 0, then x squared equals k has two real solutions or roots. X equals the positive or negative square root of k. Second, if k is equal to 0, then x squared equals k has one real solution or root. X equals 0. Third, if k is less than 0, then x squared equals k has no real solutions or roots. Example: find the solutions of the equation x squared minus 25 equals 0. First, we have to write the equation in the form x squared equals k. Then, x squared minus 25 equals 0 will become x squared equals 25. Next, get the square root of x squared and 25. X is equal to positive or negative 5. So to check, we have to substitute these values in the original equation x squared minus 25 equals 0. So if x is equal to 5, x squared minus 25 equals 0, then 5 squared minus 25 equals 0. 25 minus 25 equals 0. 0 is equal to 0. So meaning x is equal to 5 is a root of the equations x squared minus 25 equals 0. For x equals negative 5, let us substitute negative 5 to the original equation x squared minus 25 equals 0. Then, it will become a quantity of negative 5 squared minus 25 equals 0. Negative 5 times negative 5 will become positive 25. So, positive 25 minus 25 equals 0. 0 equals 0. So, they are the roots or solutions of the equation x squared minus 25 equals 0. The factoring method of solving quadratic equations is the zero product property of real numbers. It states that the product of two real numbers is 0 if and only if at least one of the factors is 0. Zero product property states that if the product of two real numbers is 0, then either of the two is equal to 0 or both numbers are equal to 0. Example: find the solutions of x squared plus 9x equals negative 8 by factoring. Solution: A. Transform the equation into standard form ax squared plus bx plus c equals 0. So, in the quadratic equation x squared plus 9x equals negative 8, we need to transpose the constant negative 8 to the left side then it will become x squared plus 9x plus 8 equals 0. B. Factor the quadratic expressions x squared plus 9x plus 8 equals 0. The factors are the quantity of x plus 1 times the quantity of x plus 8 equals 0. C. Apply the zero product property by setting each factor of the quadratic expression equal to 0. So the factors, the quantity of x plus 1 times the quantity of x plus 8 equals 0 will become x plus 1 equals 0 and x plus 8 equals 0. D. Solve each resulting equation. X plus 1 equals 0 will become x plus 1 minus 1 equals 0 minus 1. So since positive 1 and negative 1 are unlike sign, so we will subtract it. The result will be x equals negative 1. X plus 8 equals 0 will become x plus 8 minus 8 equals 0 minus 8. So x is equal to negative 8. E. Check the values of the variable obtained by substituting each in the original equation. X squared plus 9x equals negative 8. If we use x equals negative 1, x squared plus 9x equals negative 8. If we substitute negative 1 to the variable x, it will become the quantity of negative 1 squared plus 9 times the quantity of negative 1 equals negative 8. If we squared negative 1, it will become positive 1. Then positive 9 times negative 1 will be negative 9. So subtract since they are unlike sign, and we're going to copy the sign of the number who has the greater absolute value. So the result is negative 8 equals negative 8. If we use x equals negative 8, x squared plus 9x equals negative 8 will become the quantity of negative 8 squared plus 9 times the quantity of negative 8 equals negative 8. So we just substitute the value of x, which is negative 8, to all the variable x here. So negative 8 times negative 8 equals 64. Then positive 9 times negative 8 equals negative 72. So again, subtract. 64 minus 72 is equal to negative 8 equals negative 8. Completing the square is a method of solving quadratic equations that involves transforming the quadratic equation ax squared plus bx plus c equals 0 into the form the quantity of x minus h squared equals k, where k is greater than or equal to 0. For example, solve x squared minus 4x minus 4 equals 0 by completing the square. Solution. First, write the constant on the right side of the equation. That is x squared minus 4x minus 4 equals 0. Next, complete the square on the left side and add the same constant to the term on the right side. So same constant, meaning we're going to use again the constant 4. So x squared minus 4x plus 4 equals 4 plus 4. Then x squared minus 4x plus 4 equals 8. We just combine 4 plus 4. Next, write the expression on the left side as the square of a binomial. So it will become the quantity of x minus 2 squared equals 8. Then, extract the square root of both sides. Square root of the quantity of x minus 2 squared equals the square root of 8 will be equal to x minus 2 equals positive or negative 2 square root of 2. And lastly, we're going to solve for x. So x minus 2 equals positive or negative 2 square root of 2 will become x equals 2 plus 2 square root of 2, or x equals 2 minus 2 square root of 2. To check, substitute to the equation x squared minus 4x minus 4 equals 0 the values of x. So we're going to replace all the variable x here. So let us use first x equals 2 plus 2 square root of 2. So the equation x squared minus 4x minus 4 equals 0 will become the quantity of 2 plus 2 square root of 2 squared minus 4 times the quantity of 2 plus 2 square root of 2 minus 4 equals 0. Then, the quantity of 4 plus 4 square root of 2 plus 4 square root of 2 plus 4 square root of 4 minus 8 square root of 2 equals 0. So this time, we're going to add all the like terms. So 4 square root of 2 and 4 square root of 2. And of course, we're going to get the square root of 4. So it will become the quantity of 4 plus 8 square root of 2 plus 4 times 2 minus 8 square root of 2 equals 0. Then 4 plus 8 square root of 2 plus 8 minus 8 square root of 2 minus 4 equals 0. Again, add all the like terms. So we're going to add first 4 and negative 4. So 4 minus 4, since unlike sign, subtract. So 0 siya. Then 8 square root of 2 and negative 8 square root of 2, unlike sign, so subtract. So 0. Another is 8, positive 8 and negative 8. So since unlike sign, we're going to subtract. So 0 equals 0. To check, substitute to the equation x squared minus 4x minus 4 equals 0 the other value of x, which is 2 minus 2 square root of 2. So it will become the quantity of 2 minus 2 square root of 2 squared minus 4 times the quantity of 2 minus 2 square root of 2 minus 4 equals 0. So it will become the quantity of 4 minus 4 square root of 2 minus 4 square root of 2 plus 4 square root of 4 minus 8 plus 8 square root of 2 equals 0. Then, we're going to add the like terms. Negative 4 square root of 2 and negative 4 square root of 2. So since they have the same radicand and same sign, so add, it will become negative 8 square root of 2. So the result will be the quantity of 4 minus 8 square root of 2 plus 4 times 2. This 2 here comes from the square root of 4 minus 8 plus 8 square root of 2 equals 0. Then 4 minus 8 square root of 2 plus 8 minus 8 plus 8 square root of 2 minus 4 equals 0. So we're going to subtract since they are all unlike signs. So the result will be 0 equals 0. Therefore, the solution set of x squared minus 4x minus 4 equals 0 is the quantity of 2 plus 2 square root of 2 and 2 minus 2 square root of 2. Another way to find the roots of the quadratic equation is the quadratic formula. The quadratic formula states that for real numbers a, b, and c, with a is not equal to 0, the solutions of the quadratic equation ax squared plus bx plus c equals 0 are given by the quadratic formula x equals negative b, positive or negative, times the square root of b squared minus 4ac all over 2a. For example, find the solutions 2x squared plus 3x equals 27 using the quadratic formula. First, we need to write the equation in standard form. So 2x squared plus 3x minus 27 will be equals 0. Next, determine the values of a, b, and c. So a equals 2, b equals 3, and c equals negative 27. Then, substitute the values of a, b, and c in the quadratic formula. X is equal to negative b, positive or negative, times the square root of b squared minus 4ac all over 2a. So it will become x is equal to negative 3, positive or negative, times the square root of the quantity of 3 squared minus 4 times the quantity of 2 times the quantity of negative 27 all over 2 times the quantity of 2. Next, simplify the result. So, x is equal to negative 3, positive or negative, the square root of the quantity of 3 squared minus 4 times the quantity of 2 times the quantity of negative 27 all over 2 times the quantity of 2. X is equal to negative 3, positive or negative, the square root of 9 minus 4 times negative 54. Then x will be equal to negative 3, positive or negative, the square root of 9 plus 216 all over 4. Then x will be equal to negative 3, positive or negative, times the square root of 225 all over 4. So this time, we're going to get the square root of 225. The square root is 15. So x is equal to negative 3, positive or negative 15 all over 4. So if we use positive 15, we have x is equal to negative 3 plus 15 all over 4. Then x is equal to 12 all over 4. So we subtract negative 3 and 15 because they are unlike sign. Then divide 12 by 4, so x will be equal to 3. Then if we use x as negative 15, it will become x is equal to negative 3 minus 15 all over 4. Then x will be equal to negative 18 all over 4. So we add them because they are unlike sign. Then copy the common sign. Next, divide negative 18 by 4. So since we cannot divide it directly, we just need to get the LCD which is 2, so that we have the value of x equals negative 9 over 2. Lastly, check the solutions obtained against the equation 2x squared plus 3x equals 27. When x equals 3, then it will become 2 times the quantity of 3 squared plus 3 times the quantity of 3 equals 27. So 3 squared equals 9, then 2 times the quantity of 9 plus 3 times the quantity of 3 equals 27. 2 times 9 equals 18, and 3 times 3 equals 9. So 18 plus 9 equals 27. So 27 is equal to 27. Then if x is equal to negative 9 over 2, it will become 2 times the quantity of negative 9 over 2 squared plus 3 times the quantity of negative 9 over 2 equals 27. Then squared negative 9 over 2, it will become 81 all over 4, so positive. So 2 times the quantity of 81 over 4 minus 3 times 9 is equal to 27 divided by 2. It will become negative 27 all over 2 equals 27. Then, this time we're going to simplify 2 and 4. So, this time it will become 1 here, and besides 4 it will become 2. Then, it will become 81 over 2 minus 27 all over 2 equals 27. 81 over 2 minus 27 all over 2 equals 27. Subtract 81 over 2 and 27 over 2. So, unlike sign, subtract, it will become 54 over 2 equals 27. Now, divide 54 by 2, it will become 27 equals 27. So, both values of x satisfy the given equation. So, the equation 2x squared plus 3x equals 27 is true when x equals 3 or when x equals negative 9 over 2. Now, let us know what is a polynomial equation. A polynomial equation, p of x, is an equation of the form p of x is equal to a sub n, x raised to n plus a sub n minus 1, x raised to n minus 1 plus a sub n minus 2, x sub x raised to n minus 2 plus up to a sub 1, x plus a sub 0 equals 0, where a sub n is not equal to 0, where the non-negative integer n is the degree of the polynomial and coefficients a sub 0, a sub 1, a sub 2 are real numbers. For example, a x minus 2 is equal to 0. b x squared plus x minus 2 equals 0. And c x times the quantity of x minus 4 equals 0. Now, let us learn about the theorems about roots of polynomial equations. Fundamental theorem of algebra. It tells us that if p of x is a polynomial equation of degree n and with real coefficients, then it has at most n real roots. For example, a x squared plus 5x plus 6 equals 0. So, it has at most 2 real roots because of the degree n, because of its exponent 2. And b, x cubed minus 2x squared minus 4x plus 8 equals 0. It has at most 3 real roots because x cubed has the highest degree of 3. So it means it has at most 3 real roots. And c, x raised to 20 minus 1 equals 0, meaning it has at most 20 real roots. Note that the number of roots of polynomial equations is equal to the degree of the polynomial. If a root occurs n times, it is called a root of multiplicity n. Now we have the factor theorem. If the remainder comes out to be 0, then x minus r is a factor of p of x. A zero remainder obtained when applied using the remainder theorem will give rise to another theorem called the factor theorem. This is a test to find if a polynomial is a factor of another polynomial. The factor theorem states that if p of x is a polynomial and 1, p of r is equal to 0, then x minus r is a factor of p of x. 2. X minus r is a factor of p of x, then p of c is equal to 0. For example, p of x is equal to x cubed minus 2x squared minus 4x plus 8 equals 0 divided by x minus 2. X minus c will become x minus 2 equals 0. Then x is equal to 2. Solution: p of x is equal to x cubed minus 2x squared minus 4x plus 8 equals 0, where x is equal to 2. So this time we're going to substitute the value of x, which is 2, to the polynomial equation. So it will become p of 2 is equal to 2 cubed minus 2 times the quantity of 2 squared minus 4 times 2 plus 8 equals 8 minus 4 minus 8 plus 4 equals 4 minus 8 plus 4 equals negative 4 plus 4. So since they are unlike sign, subtract. So p of 2 is equal to 0. And 0 is the remainder. To check, we will use synthetic division. So since x is equal to 2, we will use it as our divisor here. Then, we need to write down all the numerical coefficients of the polynomial equations, which are 1, negative 2, negative 4, and 8. Then, first, of course, we have to bring down 1. Then, 1 times 2 equals 2. Then, add negative 2 and positive 2, unlike sign, that is why it will become 0. Then multiply 0 to 2, it will be 0. Then add negative 4 and 0, it will become negative 4. Another, multiply negative 4 to 2, then it will result to negative 8. Now add positive 8 and negative 8, it will become 0. So 0 is the remainder. The rational root theorem. Given a polynomial p of c equals a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 plus up to a sub 1 x plus a sub 0, the possible rational roots are of the form p of q, where p is the set of all factors of a sub 0 and q is the set of all factors of a sub n. The rational root theorem, for example. Determine all the possible rational roots of x cubed minus 6x squared plus 3x plus 10. Remember that the possible rational roots of rational root theorem is in the form of p of q. So meaning p, where p here is from the constant term. So we get that p in the constant term. Then for q, so we get the value of q from the term that has the highest degree of the exponent. So in the equation, x cubed minus 6x squared plus 3x plus 10, p is equal to 10 since 10 is the constant. and q is equal to 1 since x cubed is the term that has the greater that has the highest degree rather. Now, we're going to find the possible factors of 10. So it is composed of the positive and the negative factors that can be used to divide 10. So 10 has the factors of 1, negative 1, 2, negative 2, 5, negative 5, 10, and negative 10. And q equals 1 has the factor of 1 and negative 1. So from that factors of p and q, we're going to combine so that we can have the list of p of q possible rational roots, or the list of p of q possible rational roots are 1, negative 1, 2, negative 2, 5, negative 5, 10, and negative 10. So it is the combination of the possible rational roots of p, which is equal to 10, and q is equal to 1. The remainder theorem. If the polynomial p of x is divided by the quantity of x minus r, the remainder r is a constant and is equal to p of r. So r is equal to p of r. The remainder theorem states that p of r is the remainder when the polynomial p of x is divided by the quantity of x minus r. The divisor is then restated as x is equal to r. Thus, there are two ways to find the remainder when p of x is divided by the quantity of x minus r. That is, first, use synthetic division, or calculate p of r. Similarly, there are two ways to find the value of p of r. First, substitute r in the polynomial expression p of x. Second, use synthetic division. For example, p of x is equal to x cubed plus 4x squared plus 3x minus 2 equals 0 divided by x minus 3. Using the remainder theorem, we will apply x minus 3 in the form of x minus r. So, we're going to equate x minus 3 is equal to 0. Then, x will be equal to 3. So, p of x equals x cubed plus 4x squared plus 3x minus 2 is equal to 0, where x is equal to 3. This time, we're going to substitute the value of x3 in the polynomial equation. So, p of 3 is equal to the quantity of 3 cubed plus 4 times the quantity of 3 squared plus 3 times the quantity of 3 minus 2 equals 3 cubed equals 27 plus 4 times 3 squared, that is 9, plus 3 times 3 minus 2 equals 27 plus 4 times 9, that is 36, then 3 times 3, that is 9. So, 27 plus 36 plus 9 minus 2 equals, combine all the like signs, 27 plus 36 plus 9 will be equal to 72 minus 2. So, p of 3 is equal to 70. So, 70 is our remainder. Using synthetic division, we're going to check if 70 is the remainder. So, since our x is equal to 3, we will use that as our divisor. Then, we're going to write all the numerical coefficients of the polynomial equation. So 1, 4, 4, and negative 2. First, bring down 1. Then 1 multiplied to 3 will be equal to 3. Then add 4 to 3, that will result to positive 7. Then multiply 7 to 3 will be equal to 21. Next, add positive 4 to positive 21, that will be equal to 24. Then multiply 24 to 3, that will result to positive 72. So now, let us add negative 2 and positive 72. So unlike sign, meaning you're going to subtract. So the result is 70. And 70 is our remainder. Thank you for watching.